Now that we have completed the technical overview of LTE, in this section we will study LTE deployment. After completing this section, you will be able to step through LTE deployment with GSM, GPRS, H. Explain LTE deployment with GSM to UMTS, R99, HSPA, HSPA, to LTE. Explain the main drivers and objectives of self-optimization networks or SON. Describe different architecture options for SON. Here is an evolution scenario, where a network operator evolves his network from GSM GPRS Edge to LTE. Let's assume that the operator is a large operator covering both rural and urban areas. When the demand for new services such as high-speed packet is seen, it is typically the urban areas that need to be addressed first. The operator will start deploying LTE in the urban areas first. In a large network, this will result in LTE coverage appearing as islands in the middle of the largest GSM coverage area. The size and location of LTE coverage areas will be driven by market demand. In the rural areas, which do not have a demand for high data rate services, the operator can hand down LTE users to the GSM GPRS Edge network. Now, we look at an evolution scenario, where a network operator follows the 3GPP standard evolutionary path, and grows the network from GSM GPRS Edge to UMTS HSPA to LTE. The operator provides wireless voice and data service coverage to the entire service area with the GSM GPRS Edge network. In the areas where there is moderate demand for data services, the network operator may overlay UMTS HSPA over GSM GPRS Edge network to support optimized data services. Typically, urban areas are the first ones with the need for new services, such as high-speed data services. While the operator may not have deployed UMTS HSPA services as a complete overlay to the GSM-based network, every increasing demand in urban areas may be met by deploying small islands of LTE in appropriate areas. The size and location of smaller LTE coverage areas will be driven by market demand. In areas which do not have a demand for high data rate services, the operator can hand down user to UMTS HSPA and/or the GSM GPRS Edge network as dictated by the deployed network. Figure shows the GERAN and UTRAN interworking architecture. Let us now discuss the deployment example of LTE with GERAN/UTRAN. 3GPP Rule 7 specifies the feature called 3G Direct Tunnel, where the user plane goes direct between RNC and GGSN. 3GPP Rule 8 specifies an SAEGW and an MME. SW upgrade of the GGSN gives the SAEGW functionality and the MME functionality in the SGSN. LTE-capable eNode BS are introduced. The challenges faced by mobile operators is to ensure that mobile services are of a high quality, while reducing capital expenditures, CAPEX, and operational expenditures, OPEX, of complex radio access network, RAN. Rollout of LTE leads to requirement of rapidly expanding number of base station. It needs to ensure parallel operation of existing 2G, 3G, and new LTE networks. This also introduces much higher complexity in network infrastructure, operation, maintenance and management. SON is defined as a set of use cases that cover the entire network lifecycle: planning, deployment, operations, and optimization. SON algorithms are not standardized in order to allow for differentiation and competition between the infrastructure vendors. SON aims to configure LTE networks by self-configuring, self-optimizing, and self-healing functions. SON's self-configuring functions are expected to eliminate many on-site operations for the basic settings and subsequent updating of network equipment, and thus reduce capex. SON's self-optimizing functions will reduce the workload for site survey and analysis of network performances, and thus reduce OPEX. Moreover, SON's energy-saving functions reduce the costs of power consumed by the equipment. Self-optimizing and self-healing architectures improve user-perceived qualities by mitigating quality degradations that result from inaccuracies of the planning or equipment faults as early as possible, and by optimizing the network parameters under interference and overload conditions. There are three types of architectural considerations that can be deployed in the implementation of SON architecture. Centralized SON. The SON algorithms are executed at the OEM level of the existing network management systems or additional standalone servers. SON functionality and algorithms reside at the network management or NM level in the architecture. Distributed SON. The SON algorithms are executed at the network element or NE level. SON functionalities reside at the network level in the architecture. Hybrid SON. The SON algorithms are executed partly at the OEM level of management systems and partly at the network element level. It takes advantage of both the breeds, but resulting architecture and algorithms are more complex. This completes the module. Click Next topic from navigation menu.